Now let's see the advantages of round robin scheduling algorithm. Okay, there is no starvation problem in round robin scheduling algorithm. Why? Because round robin is not a first come first served scheduling. Round robin is actually not a priority based scheduling algorithm, right? It is based on first come first served, which means round robin equal to first come first served plus time quantum. And we already know that in first come first served scheduling algorithm there will not be any starvation. Why? Because the process which came first into the RAM will get the CPU for the first time. So there will not, so they are actually, the processes are actually accessing the CPU in first out order, right? So there is no starvation. Coming to first come first out scheduling algorithm, same is the case even with round robin, because in queue we were actually placing the processes in first out order, right? So even round robin will not have starvation problem. See, in priority based scheduling algorithm, as high priority processes keep on arriving to the RAM, low priority processes will starve, right? They will wait indefinitely, which means they will keep thinking that I'll get the CPU at some point, but still they are not able to get it because higher priority processes keep on arriving to the RAM. But such problems will not happen in the first come first served or round robin, because we are actually giving the CPU to the processes on the basis of their arrival time. Okay, the process which came early will be given a chance to the CPU. Only after that, the process which came next will be given to the CPU, right? So there will not be any starvation problem. Also, there is no convoy effect problem. Why there is no convoy effect problem? See, what is meant by convoy effect problem? A small process is waiting for one big process to release the CPU, right? Now here, even if a bigger process is scheduled first, it will not run for the complete time, right? A bigger process will not run till its completions. And so here, see here, a bigger process is running and a smaller process is waiting for it, right, to complete it. Now because of this, the average turnaround time and waiting time will increase. We have already seen it, right? In because of convoy effect, this is the problem. But this will not happen in round robin because we don't execute a process for such a long time. Mostly we execute it based on time quantum, which means even this process will be executed for only one time quantum. For example, if time quantum equal to 2 time units, we will be running for only 2 time units, right? So there is no convoy effect problem as well. Also, round robin is practically implementable because it is not based on burst time, unlike SJF, SRTF, longest job first, and also longest remaining time first. These are the scheduling algorithms. They are actually based on the burst time, right? Which means before executing a process itself, we need to know the burst time to apply those algorithms like SJF, shortest remaining time first, longest job first, longest remaining time first, right? But that is not the case here. Here we don't need to know anything. Here we need to know nothing, right? We don't need to know anything because we need only the arrival times, and arrival times can be easily known by placing a clock inside the computer, right? Fine. Now what about the limitation? Limitation is, see, it is not a disadvantage, it is a limitation, which means throughput is good in first come first in round robin scheduling algorithm, but it is not as good as SJF and SRTF. Why? See, coming to SJF and SRTF, they are taking the smallest processes, which means the process of the smallest burst time. So they are able to complete that smaller process in less time, and so they are able to process more number of processes. But coming to round robin, we don't pick the smaller processes. Rather, we pick processes based on first come first served, but still we execute based on time quantum, right? So throughput is definitely better than first come first served. Why? Because in first come first served, we execute the process completely. Only then we will be moving to the next process. But coming to round robin, we don't do that. We execute it only for some time and then we give the chance to the next process, right? Also, one more advantage you can add to round robin is even response time is also good, right? Response time is also good in case of round robin because we are not actually executing the complete process and then going to the next process. Rather, we execute for only some time and then we move to the next process, right? So response time here is actually less than the response time here for this process, right? For example, for process P2, the response time here is more, whereas here the response time is very less, right? So these are all the advantages and limitations of round robin scheduling algorithm. It is very popular today, right? Because it has a lot of advantages comparing to other scheduling algorithms. Fine.